Okay, here's a video of the PowerPoint slides that cover Chapter 8, Basics of Hypothesis Testing, and there's also examples here testing claims about a single proportion, a single mean, and a single standard deviation or variance. This seems unnecessary for this purpose. You can read it on the slides that I posted to the website. Same here and here. So the first most important thing we need to know about hypothesis testing is that we don't test the claims directly. We test what's called the null hypothesis, and we use the original claim to identify what that null hypothesis is, and then that tells us what we can conclude about the original claim. Excuse me. So again, this is something that we already, that seems unnecessary in this context, so I'll move forward. The null hypothesis is a statement that the value of a population parameter is greater than or equal to, less than or equal to, or just equal to some claimed value. Notice then that the null hypothesis contains equality in one way or another. We assume the null hypothesis is true and then test it directly, and then we either reject or fail to reject the null. Now, the alternative hypothesis is the statement that the parameter has a value that somehow differs from the null hypothesis. It's the complement of the null hypothesis. So if it's the complement, then it does not contain equality, and the symbolic form for those is either less than, greater than, or just not equal to. So our first three steps in a hypothesis test is to express the claim as an equation or an inequality. Then step 2 is to express the complement of the claim as an equation or an inequality, and then we label the statement that contains equality the null hypothesis, and we label its complement as the alternative. Now this corresponds to the steps that are shown on the handout on page 1 of the Chapter 8 handout. Sorry. Right here. Here's an example of a claim. The XORT method of gender selection is claimed to make the birth of a baby girl more likely if it's a girl that you seek. If it's a boy, they have a formula for boys. Something about snips and snails, I don't know. Anyway, we observe in a sample of 100 babies, 58 girls in 100 births. And so the hypothesis the claim is that with the XORT method, the proportion of girls born is greater than the 50% that occurs without any treatment. So that's step 1, to write this claim as a proportion. Proportion is greater than 0.5, greater than 50-50, the 50-50 shot you get in just normally. And then the complement then would be proportion is less than or equal to 0.5. So that means that the second statement is our null hypothesis. The first is our alternative. And as I mentioned right at the beginning, when you write the original claim in symbolic form like this, you want to make a note that that's the original claim. It'll come in handy when we get to the final conclusion. So here's our two hypotheses. The null is the proportion is less than or equal to, and the alternative is the proportion is greater than, and I don't have it indicated here or here, but that is our original claim. Now in steps 4 and 5 we decide whether we are going to use a left-tailed, right-tailed, or two-tailed test. And to do that we look at the inequality in the alternative hypothesis. It points in the direction of the test. And then we will figure out what formula to use for the test statistic and calculate that. So the inequality in the alternative hypothesis points right, and so we conduct a right-tailed test. Right-tailed test meaning that our critical value will be here in the right tail, and this red area is all of the alpha that is referred to in the question. So the inequality points to the right, so we have a right-tailed test. Now what test statistic do we use? Your handout has a fourth row in between row 2 and row 3, and we will never use that. We won't pay any attention to that. But row 1 is where we're getting the test statistic for the proportion. If we were finding a test statistic for a mean, we would use this formula, and for a standard deviation, we would use this formula. So what this formula says is the z-score, which will be our test statistic, is the sample proportion, right here, minus the population proportion, which is the presumed 0.5. And then in the denominator we will have the square root of the population proportion, the assumed population proportion of 0.5, and multiplied by its complement, which of course is going to be 1 minus 0.5 or 0.5, and we divide by the sample size, and that's our denominator. And here we have the formula, a little bigger, a little easier to see, and so we're given all of these values: population proportion, population complement, we know by default because it's 1 minus the population proportion, and the sample size, but we have to calculate the sample proportion. The sample proportion is the number of successes, 58, divided by the sample size, 100, so that's 0.58. And so in making that calculation, which we see here, we find that our test statistic, the z-score, is 1.6. Next, we want to find the critical value so that we can make a decision about whether we reject or fail to reject the null hypothesis. Because our significance level is 0.05 in this first example, our critical value is 1.645, because if you look at the table of z-scores, an area to the left of 0.95 corresponds to an area to the right of 0.05, and that is referenced with a z-score of 1.645. So we mark both of these on a graph, which is why I provided you blank graphs on the last sheet there so that you could mark these. And our critical value is 1.645. The test statistic is 1.6, and it's to the left. It's under this blue-green region, which, as we saw earlier, was the fail to reject region. And so because of that, we fail to reject the null hypothesis. The test statistic is not under the critical region, which you see indicated here, and so we fail to reject the null. And now we need to decide how to restate the decision in a way that the layman could read and understand. To do that, we follow our flowchart here. And at the start, the first question says, does the original claim contain the condition of equality? This is why you want to make a note at the very beginning of what your original claim was, so that it's quick and easy to go back and say, ah, yes, it does, or oops, no, it didn't. Well, it did not. So we follow this path. And the next question is, do we reject the null? Well, no, we failed to reject the null hypothesis, and so we word our conclusion like this. There is not sufficient sample evidence to support the claim. So there is not sufficient evidence to support the claim of right here, sorry, there's not sufficient evidence to support the claim that the XORT method is effective in increasing the probability that a baby girl will be born. I think it actually is effective, but not in this, not from this sample, and not with this, not in this example. Now, the p-value method is detailed in the slide, in the PowerPoint, and it what it boils down to is that if your test statistic is 1.6, then the area to the right of 1.6 is 0.0548, and we compare that to the significance level, and because the significance level is less than the p-value, we fail to reject the null. It corresponds exactly to what we get when we use the critical value method. And now